Hey everybody, Jason here from AV Pro Edge and Meridio. I hope you had a great Memorial Day weekend. We are back with a brand new episode in our ongoing audio expert series with Anthony Gramani. Anthony, how you doing?
I'm doing great. And everybody else?
Good to hear from you,
I'm
man. Good to
listening.
hear
I'm
from
not
you.
hearing you. Yeah, I'm doing good.
Nice to see you're back home.
Yeah, people don't know this. I was actually out of town for a little while.
Yeah, a little bit.
All of the other webinars, you may notice there were palm trees and funny backgrounds. I'm not going to go too much in the story, but I was out of the country before the whole COVID thing happened,
Sure.
taking care of in-laws, and was stuck out of the country until I could come back safely. So
Yeah.
I'm back here now.
Well, nice to see you back, and I'm glad we're back with another episode here. And today's topic is something that I find very interesting because I've spent the majority of my life listening to music a little on the louder side. And we know that this can be dangerous for not only our ears as humans, but it can also be dangerous for equipment. So you and I chit-chat a little bit, and it sounds like you have a whole entire presentation on how loud we should be listening to our music and our movies.
Yeah, actually, it's the as we were talking about putting this presentation together, I was like, well, there's some simple numbers. There's this, there's that, there's this and that. And I was writing the presentation, it's like, man, this is like all the other topics. I could go on this for hours and hours and hours, because there is the issue of how loud it's supposed to play, so you hear the movie right. There's the issue of how much you can tolerate before you go deaf.
Right.
And then there's the issue of what does your gear allow you to do given all of the above. And so you put all these three together and you end up with 200 slides, and I just didn't want to do that. So for those of you who've been listening to me ramble on other presentations, you're going to notice this one's going to be a little different. It's going to be much more of a discourse between Jason and me, or Jason and and please send in questions. Ask questions. Like, so I have a room, it's like this, and I have these speakers, and my client is this, and my client is that, and I'd love to make this a lot more interactive, because I think that's a better way to present this particular topic. So
Good.
I've got about 30 or so slides, and the rest of it will just yak away.
Sure. So I do have the question box open right in front of me, guys. So don't be shy. Feel free to send those questions in, and we'll attack those as they come in.
Great. So let's turn on the presentation here.
Great.
And as a reminder to everybody out there, you've got a little, you have the capacity of changing how you're seeing this, whether you have our little mugs, big or small. If you're watching this on a smartphone, you can swipe back and forth and you can see our faces or look at the presentation. So you have control over that on your side. And by the way, Jason, I realized that in all our chatting and preparing for this, we didn't really do a sound check. So I'm assuming I'm sounding okay, but I'm pretty fastidious about this. Want to make sure all the levels are good. So if anybody is noticing, hey, levels aren't quite right, you're overloading, I can't hear you, just let me know and we'll adjust. Okay.
Cool. Sounds good. Yeah, you look good and you sound good so far. And just a reminder, guys, real quick, the Anthony had mentioned that you can change the kind of the size of the screens and whatnot. Just keep in mind, if you're watching live, you can do that. But if you're watching the recording, you're kind of just stuck with it. So sorry, sorry about that.
Live is better.
Exactly.
Okay, so it's interesting. I named this presentation Dynamic Range. How loud is loud enough? So how loud is loud enough depends on about 1,000 different factors, including the dynamic range. What I'm going to do is I'm going to get back to the topic of dynamic range towards the end if there is time, if I haven't gone into my usual 2-hour foray. And just to explain, dynamic range is not the top level loud, but is actually the total range of what you hear from quiet to loud. In electronics gear, the dynamic range is on the bottom side is the hiss in the electronics, how well designed the piece of gear was. And there's 6 million things you can do to get the noise lower and lower and lower, each one of which costs money. And on the other side of it is what's the maximum level that this piece of electronics can do, which is based on power supply output transistors, current capacity, a whole bunch of different things. So the dynamic range in the world of electronics is just the difference between the noise floor as measured in certain standards. There's also, a 3-hour presentation on how you measure noise if you really want to go there. There's all kinds of different ways and standards, but there's a certain way that you measure the electronic noise in a system. And then the maximum level, which there's about 3,000 different ways to determine what that is, but that difference is dynamic range. Okay, in the world of electronics. And what about in the world of listening rooms? Well, dynamic range is there too. On the top side is how loud does your system play before it's either breaking or sounding like guano. I don't know if guano actually sounds like anything, but whatever, it sounds bad. And then on the bottom side, what's the bottom of the dynamic range? It's not the electronics, or usually it's not the electronics. Usually it's the background noise of the room. So ventilation noise, ambient noise around you and stuff like that. And interestingly enough, the perception of loud depends on how quiet is.
Yes.
And so we're going to talk for a while about all these numbers, all this other stuff, and then we're going to talk about, it's like, well, what do you really hear? What do you notice? Where does it sound loud? Where does your client feel like it's loud or not loud? And there's no doubt, I'm going to introduce that here, and I'm going to bring it back up towards the end. There's no doubt that in a room that has a lot of background noise, you're going to have to crank the volume up some number of decibels before you feel like, yeah, that's nice and loud.
Right.
And what that means is that now you're taxing your speakers and your amps and your power supplies and all of that other stuff. So if you want something to sound loud but not hurt your ears, start off by having a really low background noise. Funny. And then you can actually turn the master volume down a little bit, and actually possibly not listen at reference levels, but slightly below, and have a satisfying sense of loud. All right. So how loud is loud enough? So let me actually move this over here out of the way, move that over there out of the way. A lot of different panels show up when you're doing this.
While you're getting ready for that, Chris has a comment. He says, "I tried to watch Star Wars Episode 4 on disc at THX reference level. The 1977 movie. He didn't think the 1977 movie would have as much dynamics as it did. He only lasted 10 minutes and had to go down 10 dB. I haven't bought that disc. I haven't seen that one yet, so I'm not sure. But interesting comment.
So let's talk about that a little bit now, and then we'll go a little bit more into it later. There's a section here where I talk about, okay, so we've done all the math, we've done all the theory, now go measure it and listen to it. What do you notice? So I will say there is, was it Chris you mentioned that? So Chris mentioned this thing called THX Reference Level. So thank you very much, but actually THX did not invent that reference level. I just want to be clear. Remember, I started and ran home THX, so I'm going to take credit where credit is due and not give credit. Reference level is an international standard, a film industry reference standard, created over the years by a number of different people at different companies. Dolby pushed a lot of that, but even before that, there was some standards that says that when the meters read 0 on the console and everything is like at what's known the reference. Remember those things called VU meters when there was like a little 0 line? When that reads 0, the sound level at your ears is supposed to be 85 decibels of sound pressure level. That's reference level. So of course THX practiced that and refined exactly how that's measured and under what conditions and all kinds of different things like that. But that is reference level, and that's the level that's supposed to be playing in the mix room, in the actual room where the film is made, and that's where you're supposed to listen if you want to hear what the director, the sound designer, the producer, and all the other people involved wanted you to hear. The fact is that just sounds really loud. And now, why does it sound loud? There's a billion different theories. The room is smaller, this thing, that thing, this thing, that thing, and I'm going to get into that. But generally, it sounds loud. So I sometimes joke, if any of you have ever heard one of my lectures on this, I go, it's loud because all the film mixers are deaf. The good ones have been doing this for a long time, and they just can't hear anymore, which isn't entirely true. There's reasons why it could sound loud, including calibration errors. So when your meter is telling you it's, the right level, it's actually not. either errors in the meter, errors in frequency response, errors in all kinds of different things. I do find that if I fastidiously, that's a big word, fastidious, that means just super careful. If I fastidiously calibrate a system, you know, design it, engineer it, calibrate it, get everything right, and then listen at reference level, yeah, it feels loud, but it doesn't hurt your ears. It's just fine.
Right.
And I do find that most people, once they get their demo, are going to go grab the volume control, either the big round knob or in most cases the virtual knob on your remote control, and they're going to turn it down. And they're going to turn it down 3 dB at least, most often 6 or 7, sometimes 10. So remember that. We're going to come back to, like, you know, what do you really need to do, I don't know, in half an hour. So thanks for that opening question, because I've now done half of the lecture. Thank you. Thanks, Chris.
Evan asks, is that 85 dB peak or program when you mention those reference levels?
So that also is an interesting question, and that in itself could be 2 hours of talk. It's 85 C weighted, which is largely wideband. There's no, I mean, there's weighting at the top frequencies and a little bit at the bottom, but it's basically flat response, slow, average. Okay, so it's not peak. The actual peaks, depending on how you look, depending on what you call peaks and depending on how you measure, the little peaks, if you're using real pink noise, the little peaks are going to be 12 dB louder than that. And in order to find those, you'd have to measure with a really fast responding meter, and you'd have to be really careful. And it's pointless because you don't need to worry about that. Right. It's 85 dB average. Now, what you're going to set up in most consumer systems, and I'm kind of getting ahead of myself, you won't calibrate for 85. You're going to be calibrating for 75 dB, because the test generators in the actual signal generators that are in consumer surround decoders, and have been that way for close to 30 years now, are internally referenced at 10 decibels below reference. Historical fact, back in 1985 or 86 or something, Roger Dressler and I, when we were both working at Dolby, we've now moved on a long time, but we were early on in establishing those standards for home cinema, said, hey, if you turn on a test generator in the middle frequencies and have it at reference level, and when you first turn it on, most people's reaction is like, oh, Jesus, I'm going to blow my speakers out. It sounds really loud. And so it's in order to avoid that, we decided back then, so 85, 86. Roger, if you're listening, jog my memory. I forget when that was. It may have been 86, 87. I forget. Who cares? Long time ago. We decided, no, we're going to set the internal level of signal generators on surround decoders 10 dB below that 0 dB VU meter thing, just so that it wouldn't just blow your ears out. And so that confuses people, because it's like, well, is it 75? Is it 85? Blah, blah, blah. It all depends on the level of the test stimulus you're using. All right. So without further ado, wow, man, it looks like my clicker had just stopped working. Oh, beautiful.
Oh, no.
Yeah, give me a second, guys. Let's plug this thing back in. When I'm doing these presentations, I'm actually trying not to touch the keyboard.
Oh, sure.
Because it makes everything bounce around. There we go.
There was another question that came in from Magesh. He says, Dolby Atmos says 105 dB at listening position. Is it a peak or is it continuous? I think that's what we were kind of just talking about. We'll maybe get into that during your slides.
Okay. So this presentation is going great. You guys are already 5 steps ahead of me. Real quick, 105 decibels is I'm always afraid of calling it peak, because in measurements there's peak, which is 1/2 of a sine wave. There's peak to peak, which is a full peak between one side of a sine wave and the other side of the sine wave. And then there's average, and then there's RMS, so you get really confused. I'm gonna say 105 is the short-term loudest bump in sound you're gonna hear when everything is referenced per channel.
Right.
And that is often referenced to as 105 dB peak, but don't take that peak as half of the peak to peak of a sine wave. Just take that as loudest little thing that's going to play. And if your sound level meter is in the slow mode, you won't see it because it's going to average through that. You have to put it in the fast mode. And in many cases, the fast mode is maybe not fast enough depending on who made that sound level meter. So the international reference for years and years and years and years and years has been that reference level is 85 dB at the seating position, and the loudest, I'm not going to use the word peak, the loudest bumps in sound over that should be able to play 105 dB per channel without overloading, clipping, or speakers falling off the shelf. And that's per channel. So again, I'm getting way ahead of myself, and I'm going to repeat this because some of this information is important for people to know. So it usually takes 3 times before it goes in. Imagine a movie in which you have 105 dB playing in the 3 front speakers and the side left, side right, and the backs. Now what do you got? You got a lot of sound. And that loud bump in sound could be 120 decibels total at the seat position. Right. So that 105 dB per speaker could add up to a ton more. And that's when you get into this other conversation of how loud is loud, which is your sound system can do it, but are you making people lose their hearing? So let's get into this. So this course is intended to introduce the concept of dynamic range and peak SPL. Done. Reference levels and peak levels. Well, we're getting in there. We're going to talk a fair amount about the maximum level capacity of the gear. We're going to talk about reliability factors and how do you know that you're designing a system and putting it in place so that your client's not blowing up tweeters all the time. And then we're going to talk about what you can fudge. So I'm going to bring that up now, and I'm going to come back later. So what's the speed limit in the USA? Depends on where you are. You know, some freeways you can actually go as high as 75 or 80 miles per hour. You know, it used to be that it was 55. Sorry?
Up north, like in South Dakota, where headquarters is at, there's some 80s and I think 85s on the interstate.
Yeah, so that's pretty good and fast. And Europe used to be a lot faster. Interestingly enough, Europe is slower, except if you go to Germany, then you drive but beautiful, insane speeds on the freeway. So what can you fudge? And this is a very equivalent thing. In most states, whatever the posted speed limit is, in most states you can go 9 or 10 miles over that speed limit before cherries and berries show up behind you going, woo, woo, how you doing, sir? And it's the same thing with this whole topic, which is there's the actual perfect math of the stuff. There's what you can get away with and what you can get away with in terms of what people are going to perceive and what the gear can take. So we're going to talk about that for a while. All right, about me. My name's Anthony Gramani. I run 3 companies, Gramani Systems, which is a speaker company that makes really interesting, novel, new, super cool speakers that play stupid loud given their size. Actually, we make our biggest speakers, really not that big, weighs about 60 pounds, but produces 130 decibels all day long. It's really crazy. And our smaller speaker, a little thing about this big, produces in the near field about 112 dB, and it's like, Jesus, that much sound is coming from that little thing, and all good. Second company, PMI Engineering, is a design consulting company that designs home theaters, screening rooms, dubbing stages, film mix rooms, and many other acoustic-related and audio-video-related environments. Lastly, Dimension 4 Acoustics is a company that makes and sells acoustical materials for all of the above. I have a degree in electrical engineering. I have a BS in electrical engineering. That means a Bachelor of Science. And yes, I bullshit once in a while. I spent 5 years at Dolby right out of college. It was an insanely lucky and beautiful way to start a career. To be honest, I don't think I even realized when I was there just how, when I got the job, it's like, this is really cool. And then, through the 5 years there, I didn't always remember how amazing it was to work in that environment. So all of you who are enjoying your work, just remember how, when you're doing this stuff, how cool it is every day. And yeah, there's hard days, but it's cool. Then I spent 10 years at THX, starting and launching the home THX program, and then doing a bunch of other things within THX. And then 20 years ago, I decided to start my own company. Actually, it's now 21 years ago, and have enjoyed the freedom of that, which is freedom to play and freedom to work really hard. Overall, I've had 35 years of fun. I wouldn't trade it for anything at all. So let's see, I was named top 50 industry influencer by Custom Retailer magazine, top 20 industry personalities by CE Pro magazine. The work my companies have done has won many CDA awards. I've made top CDA instructor. That means I get a little gold star. It's really cute. And along the way, I did invent Surround EX when I was working at THX for Star Wars Phantom Menace. It was like the first time that we broke the paradigm in the film sound business of just 3 front speakers and 2 side surrounds, and expanded into stuff that was actually coming from behind you. Didn't exist before. I'm a CDO fellow, AES member. I have 6 patents, 2 kids, mini guitars. I'm down to 1 saxophone, actually.
Okay. Just one.
Yeah, just one. I had too many saxophones. Like, I gotta just forget this. I gotta pick and choose. And actually, you know, living overseas for 2.5 months, unpredicted, going with a suitcase for 5 days and living there for 2.5 months, I realized really don't need much as human beings.
Yeah, exactly.
You really don't. If the weather's good, you need even less. All right, I have an airplane, some old cars. The oldest one is a 1937 Morris 8. If any of you guys are gearheads, you're going to go, okay, this guy's a little wacky. Yes. Too many bicycles and too many other toys. All right. Let's get into the crux of this, the reference. What are we trying to do? So it's important to know when we talk about all of this is like, what's the intention? You know, where are we trying to go with this? So the reference I'm going to talk about a lot is film mix rooms. That's a room that could be like this. This is one of the mix rooms at Skywalker Sound. And this is a place where the film director, the film mixer, the sound designer, and anybody else involved with having a say in the sound of the movie sits and does adjustments of the console over here, adjustments of the knobs on the console over here, looks at and listens to, in this case, the movie Willow. Little known Lucasfilm property, and says, you know, I want the sound here, I want the sound there, I want it at this level, I want more bass, more treble, more this, more that, and there are no mathematical standards for how you tweak these knobs and dials. There's just, hey, what sounds good? It's kind of like cooking. Hey, you're going to cook until it tastes right, and yeah, you can apply some recipes and some chemistry to it if you want to, but ultimately it's got to taste right. And in this case, it's, you know, you do the stuff until it tastes right. And it tastes right in the reference conditions of a room like this. So this standard of quality is a film mix room. There are, you know, hundreds of these things around the world. There's probably 20 that do the majority of the Oscar-winning movies. And there's also screening rooms, which I'm going to show in a second. So those are the standards of quality in the film industry. In those rooms, the reference level, so somebody, Chris brought up, I think, this business of reference level. The reference level is that in the olden days of 0 VU meters, volume units, or, you know, when the meter read 0 on the console in the old analog days, which is today transposed into the digital world of minus 20 dBFS. That's decibels relative to full scale. So in the world of digital audio, the world kind of switched around, and rather than look at 0 and not knowing where you're peaking, things switched around, and the meters all go up to the clip point of the digital media. And it's been agreed that we need 20 dB of headroom range, just like in the analog world. So reference level is set 20 decibels below that. So when a signal is going through the console here and either registering 0 on an old analog meter or minus 20 dBFS, the sound level at the mix position shall be 85 dB SPL. I should have put C on here, pretty close. Whether you are unweighted or weighted, it's about the same. The way that's done is you put some pink noise up onto the speaker you're measuring, and you know, you set the level looking at a sound level meter, or better yet, you have a real test microphone and a real analyzer, and you set that to where you measure 85 dB with full band pink noise. And that, in my view, is a giant mistake that the film industry keeps doing. It should be done with narrow band pink noise. I'll talk about that a little bit later. So the maximum level under those conditions is simply 20 dB higher. The whole system has 20 dB of headroom. That's minus 20 dBFS. You can play 20 dB higher, which in the analog days was plus 20 VU. In the digital days is 0 dBFS. And the rules say thou shalt play 105 dB without breaking or crashing or distorting anything. So the person who asked that, there's where that comes from. It's not really much sorcery. So the way that evolved is evolution. Tape machines also, I mean, the actual recorders in the olden days were a giant form of analog recorder running film stock, actually 35 millimeter film stock coated with oxide. Those things all had 20 dB capacity over a reference flexivity. And so the gear could all do that. Actually, for a while, the recording heads would saturate when you tried to record that high, and that was all changed. Anyway, so this is how loud you can play. And is 105 dB loud? Well, it's pretty loud. It's not stupid loud, but it's pretty loud. So the loudest sound that can come out of the center speaker that's placed behind the screen, as perceived at the seating position, is 105 dB, and that's very satisfying. You want more sound level in the room, you put stuff to all of the other speakers and you turn it up, and it's more than you would ever tolerate, as Chris pointed out. So this is another room, a newer room actually at Skywalker Sound. Mix, memory failure. Anyway, so this is another room that was put together a little bit later. This one is set up for Atmos. As you can see, speakers are up here. There's some side speakers, wide channels, top channels. In the digital domain here, you can see the console where there's lots of dials and knobs, and all of this is digital, and it's all very cool. This is a smaller mix room in New York called Gigantic Films. It has our speakers in it, also set up for Atmos. All of those are standards. Now, wow, that picture transfer did not look good at all. Wow, sorry guys, not quite sure what happened there. Anyway, this is a screening room in a film studio. This also happens to be at Skywalker Sound. But when the movie is done being, mixed over in the mix room, you bring it over in here and you sit all of the people responsible for the movie in this position, typically 2/3 of the way back in the room, and you play the movie, and the director may go, I love it or I hate it. They're going to make notes and they're going to do all of this stuff. And in this room, all the same standards are applied. The reference level is 85. The peaks are 105 per channel. It's actually a little more complicated than this, but let's start with that basics. Now, those standards are well documented in a number of different references. The main ones are the ISO, International Standards Organization, standard number 2969X, and then the SMPTE, Society of Motion Picture and Television Engineers, 202M. Those are two things that if you're really bored, you can download and you can read. And if you have insomnia, it'll probably cure that.
Yeah, that'll help.
So I bring this up because this is not hearsay. This is not, stuff transmitted in a secret way from master to student. Right. No. This has been documented. Work has been done by industry luminaries to document this very clearly. So this is a diagram of a typical mixing room in the world of 5 or 7 channels. Again, there are 3 front speakers. Okay, left, center, and right speakers are behind a screen. There are surround arrays, a left side, a right side, backs that are usually split these days into a left back and a right back. And then there's the immersive layers, which I'm going to get to in a few seconds. But that adds more speakers towards the front and speakers on the top to make the formats become even more involving and more fun. And then there's subwoofers that carry the low frequency grunt of the room. So the same standards, I'm going to say this a few times, the same standards apply to mixed rooms as they do to screening rooms. Okay, all the same stuff. And theoretically, a local movie theater, if those even exist anymore, I actually had a long conversation with somebody who's very much in that, and there's a lot of fear what's going to happen in movie theaters these days. But a movie theater should be built the same way on the same standards, and they generally are for the better ones. Now, if we evolve that conversation to what happens into the world of immersive audio, whether it be Dolby Atmos, DTSX, and all of the other formats that are out there, it's a lot of the same. And here I'm expanding on the conversation of sound pressure. So follow me with this. The front channels, left, center, and right, and maybe half left and half right, that are added in the world of immersive audio that give you the ability on a really big screen to have sounds come from this part and that part of the screen without being phantom images like they were for a long time. This, interestingly enough, goes back to the early days of Tadeo 70 millimeter standards from the 50s. and not necessary in most home theaters, right? Until you have a room that's 100 or 200 feet long and a
Right.
screen that's 60, 70, 80 feet, you really don't
Mm-hmm.
need those half left and half rights. But all of those, the standards say, should play a reference of 85 dB and a peak of 105 dB. Here I put C. Okay, I've now said that about 20 times. Now, the surround arrays, which are the left surround and right surround, backs, and all of those, interestingly enough, in that environment, the reference is 83 dB for zero view or minus 20 dBFS, whatever the reference character, which doesn't say anything about how loud the movie is. It just says that's how things are calibrated.
Right.
And the peak is 103. And so where does that come from? Why is that not 85? I'll let you think about that while I drink myself a cup of tea.
And it seems like a number one, a 2 decibel difference at that level doesn't seem like a whole heck of a lot. First thing that comes to mind. Maybe it's because the surrounds are playing more subtle ambient sounds, maybe?
Actually, it's because I typoed.
That.
Woo! Sorry, guys.
Oh,
The
so it's
difference is actually
even a little
3
lower
dB.
then. There's actually
Wow.
one lower.
It's interesting how many times you can look at things and not catch a typo until it's in
Ouch.
front of everybody.
Trust
So now we have like
that.
200 people witnessing this. Yeah, well, whatever. Everybody is, failure modes. So let's see. How do I get back into presentation? Oh, and now my computer's not responding. Wonderful. I love that, the not responding, and this presentation is now over.
While you're waiting for that to catch back up, a couple of comments came in. Jonathan says, is that maybe so it creates immersion without taking away from primary vocals? Maybe because you'll hear multiple sounds concurrently. Chris says that. Tom says because there's multiple speakers. Evan says, is it lower because the surrounds are closer? Yeah, so lots of interesting responses there and good theories, yeah.
So there's this thing called legacy that drives all industries crazy, including this thing I'm working on, which is a Windows computer that has had to evolve in its legacies for years and years and try to patch things so that the old ones work. And I think Microsoft is kind of getting over that. So there's a legacy. So in the olden days, in the world of 4-channel or so, it was 85 dB. And reference level in the surround array, which was a single array, was 85 dB. So in the world of 4-channel Dolby Stereo, Dolby Surround, it was 85 all the way around. And then entered 5.1 channel audio in 1994, 1995, and the surround array was split in two. And Dolby decided, well, we're still going to make the whole surround array play 85, but the left side will be 3 dB, half of that in sound power additions. So 3 dB quieter on one side, 3 dB on the other side. So that when they come together, it's 85 and matches the front. And that was just a question of legacy in the film industry. It also allowed an older pan pot or a joystick that went from center to middle surround to maintain perceived sound level, because front center was 85, and then you went back, and when you were like trying to do a flyover of a airplane or something that goes over your head, when you pan to the back, even though there were no back speakers, it just got a sensation of going back to sound level would maintain constant sound level. So it's just a legacy, so that when the two surround arrays, the left and right sides, play together, you get 85 and match the front. And the film industry lives with that legacy, and interestingly enough, that legacy is erased into the consumer space. So when films are transferred for home application, that is now changed back up to 85. The levels are actually altered back to be non-legacy driven. There it is. That is just like everything else. You start to peel the layers of the onion, and you see many more layers. So the tops reference is 85, but the peak requirements, and what I mean by peak again is not half a peak to peak, but the loudest thing that the people at Dolby have said, we're never really going to go over 99. And now that I say 99, I'm almost wondering if I'm having a memory failure on that. It's not 100, and it's weird. We've designed many a room over the last years, and you think I can remember that. I can't. It's all in a giant spreadsheet. But basically, it has been realized that the peak sound pressure level of that speaker here, I'm pointing at one of the top speakers, by Dolby Atmos standards, don't need to play any louder. Actually, in proper English, that speaker does not need to play any louder than 85 dB. 99 dB loudest sound at the main seating area of the movie theater, which is typically considered to be about 2/3 of the way back. Okay. So now what about the bass? Interestingly enough, also through long history of legacy, which I won't get into, the reference level, when the meters read 0 or minus 20 dBFS, the reference level of the bass channel, known as the low frequency effects channel in movie theaters, is 95 dB for reference, and there's 20 dB of headroom over that, so 95 plus 20 is 115. So that's the current state of the art of what we're doing as an industry in the film business that you need to know you want to try to replicate in a proper, upscale home theater. Okay, so looking at this just a little closer, so you can see all those speakers. What Dolby has done in this diagram is illustrate in blue the added speakers that come along in the world of immersive audio for the surrounds. So before Dolby Atmos, what you had is 3 front speakers, maybe some subwoofers, and all of the red speakers over here. Introduce Atmos, and now you've got a whole array of top channel speakers, sometimes known height, sometimes known whatever. I just call them top. They're on the ceiling above you. And then some extra speakers over here that are called the wide channels. And there you have it. You have the ability to have half left and half right channels, and all of that is completely in control of the film mixer. The film mixer is the one that decides the sound is going to be either here or there or there or here. There is no automatic anything. It's just you're cooking. You decide to put salt, paprika, whatever you want to put in your mix, and there you go. It's just a pill that allows to do this.
There's a quote that I remember hearing years ago when I was studying video theory and stuff, and it really applies to audio too. And the quote specifically says, "There are no rules on how to use color, but there are rules on what color is." And it's the same thing here, right?
I like that.
We know what sound is and how it works, and at the end of the day, it's not up to me or you; it's up to the artist.
Right.
I love that.
Exactly.
There's so many parallels in audio and video. It's just it's the more I've talked to you and stuff, and the more we talk about video together, it's like, oh yeah, it's the same thing. Dynamic range, quieter room, darker room.
So the nice thing about video is in the beginning of that whole world, going back a long time, actually, going back to the 30s, the scientists decided to create standards that were all mathematically traceable, using knowledge about eyes and the psychovisuals, what do you see, what do you perceive, but reduce that to really straightforward mathematical equations that then allow to have analysis equipment and some referencing standards that aren't quite as vague as what we're doing in audio.
Right.
Like the vagary that proper sounding frequency response is actually not a flat line electroacoustically. It actually is a slightly tilted thing because of the legacy of how microphones and speakers and all this other stuff goes. So there's fudge factors all over. In video, there's basically no fudge factors. You follow the rules and everything comes together just fine. That's a part that I like doing when I do video. I like, yeah, man, and just follow the rules, and there you go. Okay. So that's the intro. First half of this is you guys just understanding where we're coming from. Now, how do we transmute this into the home cinema business? So as a reminder, full block diagram of a home cinema system would be some source devices, increasingly just a streaming device. I can't tell you the number of theaters I've done in which the 99% source is an Apple TV.
Yes.
With all its problems. The Apple TV 4 has a ton of problems, and there's much better streaming devices. It's just really convenient. It's easy to navigate. That's the majority of the source. That goes into what I call a controller, a device that is going to control what you're what you're selecting. You know, people call those AVRs or pre-pros and all this stuff. To me, it's just a
Right.
controlling device. The output of that may go to equalizers if you have a decent system, and then power amps. Maybe this may all be integrated into one box or separated
Right.
out, but these are the blocks. And the output of that goes to a bunch of speakers. And in the discussion here, we're going to talk about what is playing in the main area and what size amplifiers and what size speakers and what type of speakers you need to have to be able to replicate, if you want, everything I just talked about in the first half of the presentation. So let's start with the front speakers. So what we want to be able to do is produce 105 dB at the seating position, not at 1 meter, not at 1 inch, not at 3 feet, but actually at the seating position. We want to be able to produce 105 dB of sound pressure at the listener's ears without sounding like things are falling apart, or without blowing up tweeters, woofers, or amplifiers, okay? And that's throughout the majority of the bandwidth of the speaker. Granted, and this is again where the layers of the onion can go and go and go, there are no cases I know of where 105 dB is happening at between 6 and 12 kilohertz. That's just not the way we listen. So if you wanted to take just that one topic, this thing of 105 dB throughout the bandwidth, people could take exception to that, and we could just start talking for the next 3 hours about what's the spectral density of different movies and music and where do you need to play it. Bottom line, you need to be able to play 105 dB without noticeable distortions, clipping problems, okay?
Right.
Now, in the majority of cases, front speakers are going to be asked to reproduce between 80 hertz and 20 kilohertz because, like I talked about in how many subwoofers is enough, whenever that was, seems like a few weeks ago, I don't know.
Yeah.
I hope I convinced everybody that there's no advantage at running full bandwidth speakers. It's actually a disadvantage. You really want to use subwoofers that are separated out, and somewhere the crossover is going to be around 80 hertz. So then the big question, which is, okay, so what is the sensitivity of the speakers I should use and their power handling? And the answer is, I don't know. Depends
They're all
on
different.
6 million factors we're about to talk about. Anybody want to know? Let's calculate it. All right. So, Jason, I was saying this presentation also took a long time. I actually had about 20 slides here that I condensed into this one slide because it actually gets pretty complicated here too.
Sure.
But I've found a way to distill this down into what y'all need to do, y'all need to know, and y'all need to do in proper English, Americanish English. So the condensate of it is actually, I'm going to introduce this to the fact that the sound leaves the speaker, and right at the front of the tweeter and the woofer, there's some sound pressure, and then as it expands out and spherically expands in the room, it's going to finally reach, you know, your head and your ears, and there's going to be a bunch of things going on in the room, which I'm going to re-explain in a second. But in a 3,000 cubic foot room, which is a room that would be around 21 feet by 16 feet wide by 9 feet tall, for all y'all in the imperial system, for you other people out there in the world that got rid of that, that's an 80 cubic meter room that would be 6.4 by 4.8 by 2.7 meters. The sound pressure at the seating position is going to be what's coming out of the speaker at 1 meter anechoic minus 7 decibels. What the hell did he just say? So if a speaker is defined by the manufacturer as having 90 decibel sensitivity for 1 watt, which really there's also debate about whether it should be represented as 1 watt or 2.8 volt. 2.8 volt is 1 watt and 2.8 ohms. But what if the speaker is not 8 ohms? And you can go on and on and on and on. But whatever is the defined sensitivity of that speaker, as documented somewhere on the poop sheet for the product, and sometimes not accurately, sometimes not even. But if a speaker is documented as being 90 decibels at 1 meter in an anechoic environment, which means either a big room that's filled with 2 meters of fiberglass, 6 feet of fiberglass, or at the top of a 100-foot pole with no reflections around it, so the sound's just going from the speaker to the test microphone. If that speaker has 90 decibels of sensitivity, what you're going to hear of it is 7 decibels less in a typical room. So you're going to hear 83 dB. You follow that?
Yes.
And that, what I'm just giving you is a simplification that took years and years of lots of statistical analysis to come up with. If you actually wanted to figure this out for real, on your own, you would have to look at the anechoic fall off based on the dispersion of the speaker, look at the reflection pattern in the room, and see how much of that is coming back to the seats. Do tons and tons of math and MATLAB and element analysis and all this other stuff to come up to about the same conclusion. And this is this number I'm giving you is literally probably about 5 or 6 years of work when I was at THX to figure out, what is it? So that right here, this number, this key value is worth the hour that you're going to be listening to me here, which is whatever's the documented sensitivity of the speaker, whatever it is that the manufacturer tells you it is. You subtract 7 and you're going to find out how loud it is if you listen to it in a room that's 3,000 cubic feet. If the room is bigger, and you're sitting further. Oh, and by the way, well, you could say, well, it all depends on where you sit. Absolutely. And where you're going to sit in a typical room, about 2/3 of the way back. You move closer, you're going to gain a dB, 2 dB, 3 dB. But at a typical position in a typical 3,000 cubic foot room, it's whatever the manufacturer says is the sensitivity, take out 7, there's your value. If the room is twice the cubic volume, 6,000 cubic feet, actually that was, I didn't notice that. That was supposed to be a different format, but which is 160 cubic meters, subtract 3 dB. So 7 minus 3 is, anybody know? 10.
Big old whopping 7 minus 3? Big old whopping 4?
Well, minus 7 and subtract another 3.
Oh,
Sorry,
so
I should have said
10. Yeah.
I could have written this as sensitivity minus 10. So if a speaker is defined as 90 dB sensitivity and you put it in a 6,000 cubic foot room, you're now hearing 80 dB, 10 dB less.
Right.
You put it into a 9,000 cubic foot room, which is 240 cubic meters, and you're sitting further away and the room is bigger and the speakers is billowing out and dispersing more and losing more sound pressure level as it goes to your head. Subtract a total of 6 dB. So that would be minus 13. You know what I'm going to do as I present this? I'm going back to the times of like a blackboard where you can just change this thing at will. Yeah. Subtract 10 dB. So that would be look at this, isn't this nice? And I'm spending time on this because this is so incredibly critical. Sensitivity minus 10. And here, I found a better way to present this, see? Minus 13. All right, y'all getting this?
There you go.
From current slide. So in a 3,000 cubic foot room, sensitivity, what you're going to hear at the seating position is whatever the manufacturer said is a sensitivity minus 7. In a room twice the volume, it's minus 10. In the room 3 times the volume, and it's minus 13. Imagine what happens if you go to a 12,000 cubic foot room, it's minus 16. And this is I'm going to call this a gross simplification based on typical reverb times in the room, typical seating positions, typical dispersion of speakers, and lots and lots and lots of years of math, physics, and measurements.
Mm-hmm.
So, follow me through this?
Oh, yeah.
Now, so that's one step. So you know that a speaker, as defined by the manufacturer, that you put in the room is going to play this loud. Next thing is, well, how loud do you have to play? Remember, the rule is you're supposed to play 105 dB without the thing sounding like it's falling apart. And what does that mean? We're going to get to that in a second. So this is all based on 1 watt, more or less, and round numbers, because it all in a way depends also on the stated impedance of the speaker, and the stated impedance is one thing, and then it actually changes with frequency. So again, this is a conversation that can go on for 3 hours, and I promise I'm not going to do that today. So 100 watts is going to give you 20 dB more sound pressure level. So these are all the values at 1 watt. All the way here, and 100 watts is going to be that same number. So let's go back to that speaker that's 90 dB. Let's just put it in a 6,000 cubic foot room. So now you have 80 dB at the seat position for 1 watt. You give it 100 dB, what do you hear? 100 dB. You give it 100 watts,
100
and what
watts,
are you hearing is 80 plus 20, which is 100. Okay, so in a room that's 6,000 cubic feet, which would be somewhere around 24, 25 feet by about 18 feet, a 90 dB sensitivity speaker, which is very common, playing 100, getting 100 watts of power into it is going to give you 100 decibels at the seating position. You give it 200 watts and you're going to get 3 more decibels. So in the world of watts, every doubling of power gives you 3 dB more sound pressure level. Okay, so this whole thing that I've just jammed in here, because I would want you guys to be able to take this slide and just, you know, print it, paste it on the wall of your design room and go, this is what we're working from. This used to be 6 or 7 slides with all kinds of math, and I was like, dude, I can't. I mean, I love doing that, but I'm not going to subject you guys to that. So 2 factors you need to know is how much do you hear at the seating position of a typical room, given these basic guidelines of cubic volume, and then what does the power do? So follow me with this, and I'm going to go through this a few times. You take a 90 dB speaker, and you know, if any of you guys want to start looking on the internet and go like, what does that speaker, you know, what does this claim to be, and what does that claim to be? And you're going to see very commonly, typically 2 or 3-way speakers, you know, woofer, mid-range, tweeter. Most of those things are between 90 and 92 for the better ones, but very common that they're 90. And there's a lot of fudging done by manufacturers to claim more than they really are. And we're going to talk after this, we're going to talk about how it should be measured. And I'm going to try to convince you guys that you should be asking your manufacturers to display the data exactly that way. So 100 watts is going to give you 100 decibels. And that's before the amplifier just goes clips. It sounds like crap. 200 watts is going to give you 103. Is that enough? Well, we said that we want to play 105, right?
Yeah.
I'm not bouncing around. I'm looking for my tea. Where did I put my tea, everybody? There it is. Sorry, it's early here in California. I need some tea. I feel like I'm a a talk show host.
Morning show,
They always have a cup of coffee. Actually, you ever wonder, well, like, what's actually in there?
Half the
Is it
time
coffee?
it's empty.
Is it whiskey? Is it empty? Is it water? If anybody knows, please you know, send a note. Tell me what's typically in there. So 200 watts is going to give you 103 dB. Is that loud enough? Well, not really. What we really want is 105 and a little bit of, you know, a little extra headroom. So you really need 400 watts. Because 400 watts would add 6 dB to that, right? So I'm going to put that right in there. So I'm going to run out of room here. For 400 watts, so this is 200 watts adds 3 dB onto this number. And I'm realizing I don't really like the way that's represented, but this is, it's 200 watts colon plus 23 dB, and 400 watts gives you plus, does that read better? Do you guys follow this better? Plus 26 dB over everything else we had up there. All right, this is live and interactive. See, next time I do this presentation, it'll be more better. So if you want to play a 90 dB speaker, I'm spending a lot of time on this because this is a thing I see be done wrong over and over and over again in rooms I go to. So if you want a 90 dB speaker in a not very big room, actually, 6,000 cubic feet is really not that big. It's 24 or so feet long. You're going to need 400 watts, you know, 345 or whatever was the exact number, to be able to play 105 dB of sound without the amplifier clipping. How are you all feeling about feeding 400 watts into a speaker that's, I'm trying to get this into the picture, that's about yay big, you know, with a 6.5-inch woofer and a 1-inch tweeter? Does that feel good? Does that feel like you should be doing that to your speaker? If you feel that's good, then I recommend you go get big block V8s and stick them on your Fiat 500. See how well that's going to work.
Yeah, there you go. There you go.
It'll be fun for a little while until you hit the first turn. Yep, go ahead.
Nikolai asks, does the type of power amplifier matter in these calculations, like A, B, D, the class of the amplifier?
Yeah, that in itself is a whole discussion. Let's just say it doesn't. Let's just say an amplifier can play up or can put out to a certain voltage and decent associated current without clipping, and let's just do that. there's an entire discussion there. Some amplifiers have zero dynamic headroom over their steady state. Some of them have 3, some of them have 6. There's a whole discussion there, and some really tricky things can be done actually to have amplifiers be pretty small and put out really loud peaks. But let's just say right now that it shouldn't. And in fact, the main conversation over here isn't so much about power amps, it's about speakers, which is like, dude, are you really going to put a 400-watt amplifier on a speaker that, you know, that's about this big,
Right.
Again, with either an 8-inch, 8-inch, 4-inch, 1-inch tweeter for a 3-way, or a 6.5-inch, 1-inch tweeter 2-way. That's, and then leave it there and make sure you don't get a call on Saturday night when your client's like, you know, been drinking a bunch of these, but actually with whiskey in them, and then they grab that remote control and crank it up to impress their friends, and you want to be at home, you know, just relaxing, and what happens at 10:30? It's like ring, ring, ring. Well, I just blew up all my speakers. Come over here and fix them.
Yeah.
You don't want
pop.
Pop. Not good. So a few people may be surprised by some of these numbers. I want to remind you that the rooms we're in are not anechoic. There's probably a few of you out there that have seen the typical pro audio numbers that say that, you know, whatever's the value at 1 meter, 3 feet, at 2 meters you subtract 6 decibels, at 4 meters you subtract another 6, so 12 dB. So in an outdoor environment, or in a really big stadium environment, a place where there isn't really a reverberant field around the speaker, that is what you do in the pro audio side, which is you for every doubling of distance, you subtract 6 decibels, because the speaker is spherically radiating out in the room and dissipating energy. Well, if you have a line source, it's not quite that way. It's more like 3 dB and all this stuff. But in the rooms that we're here to talk about, which is home theaters, there is a direct field of sound. You can call that the anechoic part. I don't really know. It's just the direct sound. And then there's all these reflections. I've used this diagram to talk about a whole bunch of different things. But whether or not there are treatments, whether, whatever it is you do, there are some reflections in the room. Remember, don't over-treat the room. It should have some reflections. Those reflections from the off-axis speaker dispersion add energy back into the seating area. So if we were 4 meters away from a speaker, which is 12 feet, and you took the 1 meter anechoic value as 90 dB, when you went to 2 meters and you thought of it anechoically, which is there's no walls around, you would now lose 6 dB. And you went to the 12-foot position, which is 4 meters, you would lose 12. Okay, so that 90 dB speaker would be producing 78 dB. But in fact, there's reflections from this room that add back in, depending on the size of the room, 3, 4, 5 decibels into the loss of the direct field, because all of that energy is adding back in. And when I talked about off-axis radiation of speakers in the presentation a long time ago, when I talked about reverberant energy, remember that there is more reflected energy arriving at your ears, sum total, than direct sound. So all of that energy is in the room. And that explains the numbers in the earlier slide, which is that you're not losing 12 dB at your seating position, you're only losing 7.
Right.
So it is not 6 dB per doubling of distance. Now, why are you losing? Actually, let's go back to this. I feel like I'm a teacher that's quizzing their people. Why in a 9,000 cubic foot room are you losing 13?
There's just more space to fill out, right?
You're further away.
Yeah.
That's just the assumptions here is the size of the room, the space you're filling in, and how far you're going to be. So the 9,000 cubic foot room is going to be about 30 feet long. You're typically going to sit 2/3 of the way back of that, somewhere, 17, 18, 19, 20 feet. And so the anechoic fall off is more like 20 dB. Right? That's the direct sound fall off from the speaker to your head is 20 dB less, but the room reflections are adding back in 7 dB into that. One of the slides that I took out of this, so I wouldn't spend too much time on it, is actually showing a fall off of the direct sound and where the reverberant field is, and at what point they actually start to asymptote together, and there it is. So
that's interesting.
Maybe I should have left it in. So just remember that because the rooms we have, as long as you followed my guidelines from, I think, the last presentation, that you didn't put thick fiberglass everywhere in the room
Right.
to turn the room anechoic, but you've actually kept some reflections in the room. Remember the guideline, no more than 15% absorption in the room. So the rest of it is reflecting in the room. Your room is helping your speakers put sound pressure level into your ears. So that's why those numbers are actually easier to deal with. So I see a fair number of calculation spreadsheets and data from standards bodies and people who should know better, who continue to propagate or promulgate this idea of 6 dB per doubling of distance. And so you end up with these calculations that mean you need to have 1,000 watts of power and speakers that are,
Right.
huge. Wrong. That's not needed. I mean, you may make a lot more money from that, good for you, but it's not needed for the room. So let's review these calculations, okay? I threw a bunch of numbers at you. I'm going to put this right here so you can actually see it. So let's take this example of a 90 dB sensitivity speaker for 1 watt, which again, 1 watt, if you follow the math of the power is voltage squared and divided by the impedance. 90 dB for 1 watt is 2.8 volts going into the terminals of the speaker if it was an 8 ohm speaker. If it's properly defined by the manufacturer in a 6,000 cubic foot room, which is 160 cubic meters, this is what you're going to get. 90 minus 7 minus the 3 dB extra fudge factor for the fact that the room is twice the volume of the other one, which is minus 10. You get 80 dB for 1 watt. 100 watts is going to produce 100 dB SPL at the seat position. I keep saying this is where you're sitting. 200 watts gives you 103. 400 watts gives you 106 per channel. Okay, so if you're designing a room for a client and you're deciding, or for yourself, and you're deciding how big of an amplifier you're going to do, you need to first know, well, how big's my room? And what size speaker am I putting in there? What's its sensitivity? And all of this stuff. You can't just say, oh yeah, I'm just going to use a 120 watt amplifier. That's like saying I'm going to put a 200 horsepower engine on this car. Well, how big's the car?
Right.
How many horses are you pulling behind that car, or boats, or concrete, whatever?
Anthony, is there an alternative name for? I know you mentioned before asking your reps and stuff to give you the sensitivity numbers in more of a realistic way. Is there a name for that, or a measurement, or are you just kind of relying on whatever's on the spec sheet?
So two things. Is this a loaded question or what? So a few things. Know that in the commercial business, commercial audio, pro audio and commercial audio, you really can't get away with disclosing something that's wrong, either because you measured it wrong or because you were fudging. Your people are going to be all over you right away, like flies on you know what. And you can sort of rely on the spec sheet from any one of the decent, good quality, reputable manufacturers making commercial audio gear to be accurate. An hour. How does that happen?
I know, it's just so crazy.
We're almost done. So you can rely on that on the commercial side. On the consumer side, it's all over the place. And there's a lot of reasons why it's wrong, and I won't go into that. So now what? How do you know? Well, like I said, ask, if you can't find a proper specification that looks like it doesn't have a bunch of marketing all over it, but it's like a boring black and white sheet of charts and a bunch of numbers that are not made to look good. If you can't find that for your favorite product, ask the rep, hey, I'm looking for a real engineering spec sheet on this product. Can you get me that? If they say, well, I don't really know, I don't know who to ask, then pick up the phone, call the manufacturer and go, I want to talk to your engineering department. And they go, what? And you just say, look, this is what I'm trying to do. I'm a really important person in this industry. We're all really important. And I'm trying to design this so that I don't have to return that speaker to you. I don't want to put that in, have it blow up, and then call for an RMA while it's under warranty and charge you for taking it out of my client's place, pulling the screen down, taking it out and sending it back to you and wanting my money back. So if you want to avoid that, please put me in touch with engineering so I can talk to somebody to find out what is the actual sensitivity for 2.8 volts for the speaker. And the person on the phone, the receptionist, like, whoa, there's somebody that's really pretty intense on the phone. Here, let's.
Sir, I'm gonna transfer you.
Yeah, I'm gonna transfer you to our security department. So that's that's one long answer to that question. The other one is, and I've mentioned this a few times, I'm working on a committee within CEDIA to try to standardize all this. And
Right.
what that would do is the manufacturer voluntarily, and also CEDIA would show you a poop sheet, a very simple data chart
Hmm.
that's not pretty. It has a picture of the speaker, a name of the thing, a CDL logo, manufacturer's logo, and gives you all this kind of info, including the real sensitivity, the real impedance, the real admissible voltage and current, and all of those things that if you know how to design following these rules, you'll be able to do a good job and guarantee that your client's going to be happy, and you won't be rudely forced to go into rain and snow Saturday night at 10:30 to go fix something.
Sure.
So this is an example. Let's go a little further. But wait, there's more. So everything I've talked about right now is these global numbers, but in reality, a speaker that is stated as a 90 dB speaker that maybe the manufacturer says it can take 200 watts. I forgot to mention that. So, you look at the typical marketing-oriented sheet on a speaker. It'll give you weights, dimension, sometimes sensitivity, but almost always power handling. And the power handling, if it's done correctly, and I'll show you a little later what that means, is saying by kind of rule of law that you should be able to put that much power into the speaker, go to lunch, come back, and the speaker hasn't blown up. And that would be the actual test signal would be a form of pink noise that's stimulating the majority of the speaker, and that's what it's supposed to be able to take without blowing up. Okay, but wait, there's more. Most speakers can take 6 dB more short-term voltage or power and not blow up. Some of them can take, there's a lot of speakers, you'd be surprised, a typical 6.5-inch two-way, you can give them 1,000 watts for, a quarter second, and
Sure.
they'll be fine. Maybe the woofer will go bang and you'll hear it do something ugly.
Right.
Maybe it won't sound perfect, but you won't blow it up. Now that I've said that, I'm feeling like I'm telling everybody to, inject, disinfectants. Don't try this at home. Don't trust me for it. I've seen speakers that, because the voice coils and everything was designed well, that are stated as a 150 watt speaker, be able to take 1,000 watts without having any problem at all, short term.
Right.
So
split second.
Wouldn't you want to know? Wouldn't you want the manufacturer to tell you this is the admissible power for long term, admissible power for midterm, admissible power for short term?
Mm-hmm.
You would. And you would want to know what short-term, midterm, and long-term means. And that's one of the things I'm trying to do with NCEDIA. So when you get that poop sheet of, plain black text on white background with no marketing anything, it's actually going to tell you what can you do with this. So I'm going to give credit where credit is due. The people at Genelec have been telling you that for years.
Yeah.
If you look at a Genelec poop sheet from either their pro audio or commercial side or consumer side, actually the consumer has been dumbing down a little bit, but it actually, on the pro side, it will actually tell you what it can take given these different lengths of test signal. So the fact is, most speakers can take at least, or can take the power and produce sound pressure level at 6 dB louder for short-term peaks. So what that means is that whole thing I just talked about a second ago, which is if you want to play 106 dB peaks, you do need the power to drive them.
Right.
If the amplifier is only 100 watt amp, it's going to clip when you try to make it produce 400 watts on typical amplifier topologies. And I know there was a question on that, and depends on the dynamic capability of the amp or whatever. But you can actually put a 400 watt amplifier on a speaker that's designed to be only 100, 150 watts, and know that in most cases, only the short peaks are going to be going at that level into the speaker, and it will be okay, as long as your client is not like falling off their ass with whiskey and cranking the level up to +10 to impress their friends, and that's where problems start. So there's where the fudge factors start. Do you know if your client's actually kind of heavy-footed and is going to actually crank things up to impress people or not? Do you want to take that chance? And I can't tell you. I just want to tell you that you can probably put 400 watts into a speaker that's 90 dB sensitivity in a room that's 6,000 cubic feet and play a movie at reference level where the peaks are 105, 106, and you'll be fine in most cases. If you blow up a speaker, don't come back to me because I can't control what your speaker manufacturer is doing. I'm just giving you an average on this. So
Chris mentioned real quick, he said he saw in another video with Pro Audio Technology, they played 105 dB reference level at a 30-foot distance with 3 dB overhead in a system for 2 hours. That's how they were Dolby certified, apparently. 2 hours straight.
Dolby certified is this interesting thing.
Yeah, yeah, I'm not sure exactly what he means there. But yeah, 105 decibels at 30 feet for 2 hours straight.
Right. So
Yeah.
what the reference may be is that if you're building an Atmos, if you're building a mix room that you want to do Atmos mixes in, Dolby says we got to come over and look at this thing. They ask for the plans, they ask for all this data, they ask for data on the speakers, and we've been through that. Actually, Guarani Systems, a lot of the speakers are certified. There's a bunch of mix rooms that use the speakers. So Dolby does want to know that the system you're putting into the room has the capacity to do what it's got to do. And in a small room, it's smaller speakers. In bigger room, it's bigger speakers. And Pro Audio must have gone through that testing. I would call it a room-related certification, but that's the thing, is you need to be able to play that signal for a decent amount of time. But wait, there's more. I'm going to get into how that really should be measured in a second. So next thing you need to know, I don't know if you remember, but in the introduction of this, I talked about, well, what are the fudge factors? So one fudge factor is you don't need to put a system in place that can play the full 105 dB all day long, like we just talked about with Pro Audio. That is something you want to do in a professional mix environment where you'd be working for 8 hours on this thing. You want to make sure the speaker doesn't blow up, because if it does blow up, the entire session is down. Now you have to wait for Paul Hales to show up with a new bunch of tweeters to fix them. Interesting. I just got a pop-up that said that I've been signed out because I'm currently signed onto another device. I have no idea what that means. I'm still here, right?
Yeah, you're here. Yeah.
Interesting. Okay, so first fudge factor is you can get away with the 6 dB fudge, which is really cool because now you don't need as big of a speaker system. Second fudge factor is realize that most program material has a ratio between the average levels and the peak levels of about 10 dB. So what I mean by that is if you take a movie and you put it through an averaging meter, voltmeter, looking at the center output, then you look at what its average is over the 2 hours of a movie, and you go, well, here's the average voltage, and then you look at, let's look at a peak during a really, high action scene. That difference is 10 dB. So the whole idea of the long-term capacity of a speaker, which is really a thermal thing, you don't want the little wires on the coils to burn up, is realize that most movies are not going to be sitting there at 100 dB or 106 dB most of the time. They're going to be playing 75 to 80 dB most of the time in dialogue scenes and stuff, and then there's going to be a peak at 105 dB per channel, which may add 120 total. But your speaker is not going to be heating up for that whole time. So there's another fudge factor.
It's the same with video, man. It's so funny.
Yeah. So long. Go ahead.
It's about those peak highlights, the specular highlights. The average movie might be 100, 120 nits, but you'll get that bright flash of 1,000 for just a second off a reflection or something. You're not blasting 1,000 nits for the whole movie. It's nuts.
Right. So in the olden days, in the days of CRTs, you could totally take advantage of that because of lots of things about how CRTs and their power supplies work. Today, in digital displays, it's a different factor, but those fudge factors need to be known and used. All right, so remember that the long-term, like what the long-term data is for, is one is an overall sense of power. You do want to know that the system can play loud enough so that it can sustain a certain sense of volume. Knowing that that sense of volume is 6 to 10 dB below the little peaks, the little short bursts that are going over there. If you put speakers that are entirely too small, when you crank it up, it's just not going to sound loud.
Right.
Okay. And then you have to decide, well, what does sound loud means? And you could say, I'm going to design a system so it plays 105 no matter what. And then and that's one way to do it. That's like designing a car with 600 horsepower that you're just going to drive around on the freeway when you're using 70. Well, you got a lot of headroom. When you push that right pedal, man, it's going to go. And that's one way to design a system. If you're On the other hand, if you're actually up against a competing bid from some other company where they put smaller speakers and all this other stuff, and you're like, man, how am I going to make this work? Just know that you can start to fudge. And you can reduce the size of the amps and the speakers and all that given the data I'm showing you. But if you go too small, then it's just not going to sound right. So what is right? I would say a good target is to design a system so it can play 100 dB long term and 106 dB short term. And I'm hoping I'm giving you enough equipment here to understand what that means. So long term is about overall sense of what I'm calling power, not watts, but the sense of volume power.
Sure.
And reliability. So know that if you're going to under-design the system with that fudge, there's always the risk that on normal days everything is fine, and then that Saturday after just a few too many glasses of whatever, you get a phone call, or you get a phone call, and usually at that point the clients had one too many drinks, and their overall sense of dignity and fairness is gone, and they're yelling at you, and they're using all kinds of profane language you really don't deserve. So on the other side, short term, what's the short-term peaks? What are those about? It's about the sense of dynamics. If you can play those peaks without clipping, without crashing, you'll get a sense that the system is dynamic. And you want to make sure there's no clipping or overload distortion, because if you actually do hear distortion, it just sounds bad, and your client's friends are going, that guy ain't so good.
Yeah, they're like, no way.
Yeah. So, what do you notice? So, number one, 120 dB total is just really loud. So imagine you did design a system that played a full 105 dB long term out of all of the channels, which is what you want to do in a film mix room when professionals are working, or you want to do for a client that you want to make sure never has any problem. When you crank a movie at reference level, there are going to be scenes that play that produce 120 dB total at your ear, or if that volume's gone up a little bit, you could get to 125, and that's just really loud. Do you really need to do that? And so that's one thing. The other thing is, as you crank volumes up, you're getting close to the limit of the speakers, and you're starting to clip the amplifier. Well, know that most people don't hear distortion until it goes clearly over 1%.
Sure.
At 1% distortion, while you can hear it on a single tone, on 1 kilohertz or 500 hertz tone, on regular program material, movies or music, you just don't notice it. So you can actually get away with some distortion without noticing it. Long term, again, it's about reliability. So what can you notice? You'll notice that the reliability of the system is not good when you're popping tweeters or woofers or other things. So on the short term, note that short clips are not noticeable if they're much shorter than 10 milliseconds, which is an eternity when it comes to electronics. What I mean by that is if a little peak is going by, and if you actually looked at it on an oscilloscope, if you had a way to look at that the amplifier is clipping, if it's shorter than 10 milliseconds, most people won't notice it. Critical listeners will certainly notice it, but most people won't. And interestingly enough, it depends on the room reverberation. Because that little clip that lasts 10 milliseconds, if you put it in a room that has a second worth of reverberation time, now that clip is propagating through all the reverberation, and now your auditory system can actually hear it. So some of that depends on the room. In a typical room that we're going to design correctly with a reverb time is 0.2 to 0.3 seconds, this is what you can get away with. Okay, these are all the fudge factors, right? So I first gave you the theory of what you need to do so that by the book you're following, the 55 mile per hour speed limit. Well, you can get away with a little more. So, all right, now, how does this all get measured? How does this, how do you, there's some math to design it, and then how do you measure that it's right? So first of all, the speaker measurements. I mentioned a few times before that the sensitivity and the power handling, and really the disclosure of peak sound level capacity of the speaker, which you will find in commercial audio specification sheets, and you will find in this CEDIA sanctioned data sheet, should be measured per the very cool AES2 standards, which is a very smart statistical process that says this. It's very cool the way it's done. So you send the speaker over, actually the manufacturer should send the speaker to one of the accredited test labs that exist around the world. There's 3 in the US and a bunch of them in other countries. And they actually measure the speaker in this complicated process, but it amounts to measuring the speaker at low level and looking at its frequency response. And then with pink noise, a certain tailored, it's actually not pink, it's actually pseudo-random noise, you start to turn the level up while measuring its frequency response. And you turn it up, and you turn it up, and you turn it up, and you turn it up until you see something in the frequency response deviating from what was the reference at low level. And when there's a deviation in excess of 3 decibels from the original level, it is known that if you try to play 1 or 2 dB louder, something's going to give.
Right.
On a powered speaker, the amplifier, if it's well designed, is going to limit. So there won't be destruction, you just won't play louder. On a regular passive speaker, there's a really good chance, there's a 90% chance that if you play much louder than that point where there's a 3 dB error, you're going to break the speaker.
Right.
It's going to the tweeter in most cases, but sometimes the crossover, something else, could actually become a fuse. It's actually going to open circuit, and there won't be any sound at that driver.
I've seen some voice coils melted together before in car audio, my old car audio days, from being overdriven and just distorted to death. Yeah.
So the most common thing is a thermal overload for this test. So in most conditions, as you start to crank up on a passive speaker, or I would say an incompetently designed powered speaker where they didn't put limiters, or something to protect the speaker, you're going to have a driver failure, like you said, melted voice coils. But I've actually seen crossovers fail. Actually, yeah. I've worked on a system, blah blah blah, and tried to test it and try to make it blow up. It did blow up, but the woofer, the tweeter, the mid-range didn't blow up. It was actually a coil inside the crossover that went over its thermal capacity by the design of the speaker. So something's going to fail. What actually happens for this 3 dB error? It's interesting. You either get power compression in one of the drivers. You get excursion limit in one of the drivers. So rather than let's say it's a 3-way speaker, the tweeter's got plenty of headroom, the woofer's got plenty of headroom, but the mid-range doesn't. At some point, that mid-range is reaching its maximum point, and it's either power compressing, as in the coil's becoming a little space heater and its resistance has gone up, or the excursion just can't push any more air, and so you're going to see an error in the frequency response. And so this whole process, this is actually really interesting to read all of the data behind how this was done. It's very cool, but extremely relevant. So ideally, when you're looking at the spec sheet from the manufacturer, where does the time go?
I'm telling you, man,
spec sheet. Like I said, I could talk about this also for 2 hours. Look at the spec sheet from the manufacturer, and it says 90 dB. Ideally, what you want to see, brackets AES2. And you will see that on professional audio speakers and commercial audio speakers, and you should be asking your vendor. So your favorite brand of speakers you're working with, ask the rep, call the company, go, are you measuring this with AES2? And when you finally get a hold of the engineer on the other line, they may go, what?
You actually know what that is?
Well, they may not even know. I'm surprised how many consumer manufacturers don't know.
They might not know. Oh,
yeah.
Interesting.
It's really too bad. Very, very good work was done by very, very top people in the field to come up with the standard, and it should be applied. Okay, the other thing that could go wrong on a powered speaker or on a system that has an amplifier and a speaker when you crank it up is the amplifier could overload. So you're turning the speaker up. Suddenly the amplifier that drives the woofer can't go no more. Well, it's clipping. It's not playing any louder. You turn up and the tweeter is turning up, but the woofer's not going any further. And what that means is it's going to sound bad. Or you could have an amp failure. It takes a lot to fail an amp, for an amp to fail based on overload and clipping, but long enough, thermally, it could actually just go, all right, my output transistor is just really unhappy. I'm going bye-bye. Or some other part could actually go into failure mode. So that's about measuring speakers. And so all this data I just told you about, you need to know the sensitivity of the speaker, the power handling, short-term, long-term, ideally the peak sound pressure level capacity of the speaker, the size of the room, the reverb, how far you're sitting, all of that. None of that's relevant if you actually don't have a real good value of the sensitivity of the speaker as measured in a professionally calibrated certified room, and if you don't know what the overload capacity is. Okay, so next thing is how about confirming this in the room? So first, now I'm going back to, was it Chris's question an hour and 20 minutes ago?
Mm-hmm.
So how do you know that you've got true reference level? How do you know that you actually have the system, when the volume is at the 0 position or whatever you've defined as reference level? It used to be that products had a point called reference position, and you would calibrate for that. And you calibrated by using mid-range pink noise. So not broadband pink noise, but pink noise that's been internally set and limited to 500 hertz to 2 kilohertz, and set at a level so that its value is 10 dB below reference. You calibrate that to be 75 dB SPL using the internal test tone of a surround decoder if it's correctly built, although I've seen a lot of them out there that are not correctly done. A reliable signal source is an external signal source, just
Mm-hmm.
because a lot of the internal generators are not really that good anymore. And so there's a test disc I created with Goldline years and years and years ago called the TK51. I think you can still buy it. That's got a whole bunch of test signals on it. Dolby Atmos does issue test discs, but those test discs have wideband pink noise on them, so you can't really do this mid-range thing. So why use mid-range pink noise? This is about 20 slides that I took out. If you use wideband pink, the variations in bass from one seat position to another seat position, from one speaker to another speaker, could actually change your measured value by 2 or 3 dB, while the mid-range doesn't change. You don't want that uncertainty to affect your measurement. So get rid of the bass, get rid of the treble, because there's also variations in the treble. Look at the mid-range, which is where your sensation to sound pressure level really is set. And using that stimulus, mid-range only, that doesn't have the variations in bass and treble, and also the microphone's variations in bass and treble, which is on lower cost sound level meters, is pretty significant, and measure with that, calibrate with that. So depending on the source you're using, there are different test signals. On the TK51, it's the 5.1 audio toolkit, although it was designed for EX for multi-channel sound going all the way around. There are test signals in there that are mid-range that are made to be measured at 75 dB. There's also full range that are meant for 85. Just follow the instructions. The Dolby Atmos test disc, I'll write this right back in here.
Real quick, while you're doing that, I did just do a quick Google search, and that TK51 disc still is out there.
Okay.
Looks like
Great.
it's about $60 most places.
Right. My computer's not responding, so you guys are watching the little circular thing. Okay. I hope that doesn't mean that this presentation is over. Anyway, so the Dolby test disc has actually got full band pink noise at 89 dB. Long story. They should have put it at 85, but then there's this thing called dialogue normalization that changes all that. It gets like crazy. This is another one of those issues of legacy will really screw you up. So I'm going to put this on here, 75 dBc for mid-range pink. Mid-reb, can you pronounce that? Mid-range pink. And on the Dolby Atmos test discs that you can get, most dealers, if you're right into Dolby, you go to a trade show, whatever, you can get these discs. They're usually purple. They have all kinds of really cool demos. Sure. That's 89 dBc with full band pink, which is again a dangerous signal to use because you never know if your errors in bass from seat to seat, like I had presented in the subwoofer session, are going to screw you up. So what you can do if you're using full band pink is you can use a weighting on your meter that removes the bass and then turn everything down 3 dB from where you were before. And there it is. Okay, use a calibrated meter. Sorry, your smartphone is not okay.
Thank you for mentioning that, by the way.
You can get, you're welcome. You can get all kinds of measurement tools for audio for this, things that have meters, but they don't know what the actual gain factor of your microphone and your everything inside is. You could calibrate it. Most of them are calibratable, and to calibrate it, you would need to have a really good test microphone and compare it against that. So if you have one, if you went out and invested the $70 you should invest on one of the USB mics, there you go. Beautiful. I love that. You can compare against that thing. And then at that point, you have something that's sort of okay for mid-range pink. Don't rely on it for bass or treble. Okay. Now, when you are calibrating, to make sure that what you're hearing is what the director intended, so that it's not too loud or not too quiet, you want to make sure you do some spatial averaging. So don't just hold a meter like right here. Move it around a little bit and look at the needle or the simulated needle or the numbers bounce around and try to get an average. You want to hold the mic at ear level, not down here. I see a lot of people holding at their bellies. Well, that your belly's not listening, unless you're talking about food. And average the signal fluctuation. So you're going to see the needle bouncing around. You kind of have to eyeball through that. Okay.
Right.
Now, if you do it right, you know what? I'm going to add in here. Consider using use a weighting with minus 3 dB. Well, the A weighting, depending on the meter, is going to remove 3 dB of energy, so it's really a 3 dB fudge factor. Now, one of the things about calibrations that I do want to point out is when you're calibrating levels, you're doing two things. First and most important is you're calibrating all the speakers relative to each other, so that given the same input signal, you're getting the same output. That's the most important. Second thing is you're calibrating for reference level, so you hear the sound level that the mixer heard. And I would say that's important, but probably secondary. It's really nice to hear it the way the mixer intended. So I'm going to conclude this hour presentation that's gone a half an hour long by saying this. If you do it right in a small room being your 6,000 cubic foot room rather than the 60,000 cubic foot room that they makes the movie in. If you do everything right and the frequency response of your speakers are right and you measured it right and you use the right stimulus and you bring a film mixer, you actually bring the person who won the Oscar for mixing that movie into your room. And I've done this. I had the good fortune of working at Dolby and then Lucasfilm THX amongst a bunch of film mixers, and I could go, okay, come over here, come over here and listen to Saving Private Ryan, listen to Star Wars that you just got done mixing. Tell me, does this sound right? And they're going to be within a dB of what they intended. You can actually fudge it. You can turn it down 1 dB and go, does this sound right? And they're going to go, it's a little quiet. Okay, here's a remote control. Turn it up and down until you're happy with it. They're gonna go right back up 1 dB because they know exactly what it was supposed to sound like. So there's a lot of controversy out there that goes, oh, in small rooms you should play quieter because the perception is this and that. It's like, if you want to hear it the way the mixer intended, you will follow the rules I just put out here.
Sure.
Which doesn't mean that you have to listen to it that way, because it is pretty loud.
Right.
So just, it's the same thing as going to a concert. The front of house mixer just loves it stupid loud. Either they just like it that way or they're deaf, probably a bit of both. And the more they like it loud, the deafer they got. So, you sit there and without earplugs on, you're like, ah.
Yeah.
So if you do it right, film mixers will tell you it's right. If you don't do it right, if the frequency response has some errors, if the meter you're using isn't right, if you're not following all the rules, the actual perception of sound level won't match what the director intended. And that's kind of the important part. So before I go to the sort of conclusion of this, are there any other questions that popped up?
Yeah, there's a couple actually. Adam mentions, and I'm not familiar with this, maybe you are, NIOSH, N-I-O-S-H.
Yeah.
Did a study recently. Over 50 apps indicated that only one was within 5 dB of accuracy. He's mentioning the SPL apps on your smartphone.
Yeah.
A similar iOS study showed that among 130 apps, only 3 were within 2 dB of accuracy. Even handheld SPL meters out of the box were to be found to be as much as 4 dB away from their standard spec. So again, we'll go back to this. I know you said it a bunch. I try to live by this all the time. You have the tool to calibrate something, but something has to calibrate the tool every so often. So I'm thinking with these apps and some of these handheld devices, as long as you calibrate them, you're probably fine, but you cannot just rely on them out of the box.
Absolutely. Thanks for bringing that up. So I'm actually even surprised that they said an app, because to me it's the app running on a certain phone. This version of iPhone versus the next one or the one before, the same app is going to have a different thing potentially. So, and maybe the app is tracking which phone it's loaded in. I don't really know about that. I'll have to go look at that NIOSH information. So interestingly enough, for the record, that old Radio Shack $39 SPL meter, the old one, the analog one with a meter, we had measured hundreds when I was at THX. Every time somebody would come over for the THX trainings, we would ask them to bring their SPL meter, and we would calibrate them during the training, and they were usually within 1 dB.
Nice. Yeah, that's the one I've had for at least 15 years at least. Yeah.
Right. Unfortunately, that thing with the needle breaks if you drop it, which is usually how mine have died, or they just break when you transport them because they weren't very solid. But Radio Shack, you know, their manufacturer, wherever it was in Asia, showed that you could actually make a really cheap meter, calibrated correctly, and work perfectly fine.
Sure.
So that's interesting. I'll have to look at that data to see. Are they mentioning any names, or are they just saying
no?
The number? Oh, okay.
Yeah, no, nothing specific. Top says this goes back to the very beginning. Which airplane do you have?
It's an old Piper Cherokee 180, 1969. Cool. It's old, but it works. Great
Dan
for social distancing.
Oh, sure. Yeah, there you go. You had mentioned before, we briefly mentioned that a lot of systems right now have just a simple streaming box as their source. Dan asks, and this might just be a kind of opinion piece here, but what are the best streaming sources? I have a few that I like. I am a big fan of using the TV's internal apps as much as I can, but not every app is in the TV. So personally, I do have a Roku and an Apple TV and a Chromecast. And I find that using the Roku for me seems to work really well. So does the Apple TV in a lot of cases, but I'm a big fan personally of getting it from the TV if I can.
So that's an interesting question, and the guy who works for me, Chase, is tracking this every day, and every day I'm getting different reports about, well, the Roku used to rig perfectly on this application. They just updated, and now it's broken. And broken being that the levels are wrong, there's distortion, there's this thing and that thing. So the answer is, I don't really know because it changes all the time. By and large, I found that the piece of hardware called Roku and the apps that run on it are more often accurate and correct for picture and sound. So I'm being very kind of soft about this because it changes all the time. And sometimes the Chromecast is working fine. Sometimes it's not, depending on what version of the app it's running. So that's fraught with problems. I've you know, as you see, we always run out of time, and I do have this long-term project of building a wiki where we're constantly updating the information of what we're finding in those different pieces of streaming equipment, and maybe that's something we can do together.
Maybe
Jason, if you guys want to host that or whatever, I would just keep feeding. Chief Swalton's the guy who works for me, who's tracking this all the time.
We've certainly got switches and analyzers, and we got enough stuff here, I think, to figure it out. He asked specifically about the NVIDIA Shield. I don't have a lot of experience with it. I know a lot of guys on the forums are big fans of the NVIDIA Shield. I haven't personally played with it though yet, so I can't say, unfortunately.
Yeah. That question, if you can track who wrote it, send me an email or whatever. Maybe what I'll do as a follow-up of this is have Chase write kind of a little summary of what we're finding these days in the most important apps and the most important streaming devices. And you'd be amazed what sometimes goes wrong. And he'll do these comparative things, like looking at the same app on 4 different streaming devices using the same source material, and you see all these differences, you hear all these differences. One is playing Atmos the right way, the other one is not. Levels are wrong, and it's all over the place. And then you look at the same program material through different apps, and that's yet again completely different. So it is maddening. Now, let me say this: it's maddening if you believe in offering reference picture and sound to your client, and the client who's just buying a 55-inch TV set with a sound bar, whatever. The client that's buying a $650,000 reference theater from you with a 160-inch screen, really expensive projector, reference sound quality, the fact that in the end the experience is subject to what's coming from that little streaming box is a problem. And so, is there an answer to that? I don't really know. I would say that if there's enough budget, so this is a little plug. I would say if there's enough budget in there for both the hardware and the software, I would look at what the guys from Kaleidoscape are doing, because they do care more about referencing their hardware and software than a lot of other people. So that's a good way to ensure that that's all working. And I don't get paid for by Kaleidoscape to do this, to say this.
Yeah.
It's just that it more often, you're getting closer to the source on that. So.
I think there's probably two more questions I think we have time for, and then we'll have to probably wrap it up from there. But Jonathan says, when mixing for home use in most consumer level applications, I mix the reference volume to the center channel. If at reference the center produces 72 dB or 69 dB, I use that as the baseline for mixing the rest of the speaker's response. I do use the -2, -3 for surround speakers. Is that a good way to do it for off the shelf for just core audio applications in homes?
I'm sorry, when you Jonathan, when you say mixing, as in, are you a
I think
remixing
he
engineer? Or?
setting levels in like a home cinema, home theater type situation. He's measuring
No,
the center channel, then matching everything else to the center channel, assuming all he has is an SPL meter. That sounds about right.
Yep. So that's interesting. Absolutely, the most important channel is the center channel. Now, you could say, well, it doesn't matter what's most important. If I've got signal generator schemes, either in reference test disks, or if you trust the internal test generator in the surround decoder, which I wouldn't, because I've seen them be all over the place, but if you can trust it, then all the speakers should measure 75 dB SPL from the internal test signals or the signals on the disk, or 89 if it's the Dolby test disk. And so all these fudge factors you don't need to worry about. But ultimately, yes, everything should match the center as close as possible. I will say this. If you calibrate it that way, most of your clients are going to go, I don't really hear the surrounds. I don't hear the tops. I paid for all this, So a lot of times you're going to have to turn up the side and back speakers 2 or 3 dB so that your client's happy with their investment. Then you're not hearing what the director intended or the mixer intended, but the client's happier. You're going to have to turn up the subwoofers about 3, 4, 5, sometimes 10 dB so that they're happy, and it's like boom, 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 and they're happy that their subwoofers are there. So just be aware that there is a reference, which is all channels would measure the exact same level on a proper meter that you're moving around a little bit. And sometimes to make the client happy, you're going to have to be prepared to turn up, the surround field a few decibels. Yeah. And then you'll notice on some movies it's too much surround. It's like, man, I can't hear the dialogue anymore. So
it's like becomes something I've heard over the years many times is preference versus reference. Yeah, you like a little more bass, then you're not going to hurt anybody, right? Okay, and then last question. Adam mentions when we're talking about how loud is loud enough, if we could maybe mention just quickly about appropriate listening levels, maybe some hearing protection and hearing loss. I will say, just as an avid concert goer and somebody who likes live music, I haven't left my house without earplugs for at least 10 years. I've got a nice little set of Etymotic that are supposedly, this actually would be an interesting thing to try to measure, but supposedly the Etymonics, they take out so many dBs without really altering the sound too much. I think that's pretty interesting, versus putting in the little foam ones, which totally change the sound and they make it quieter. So do you run into this at all when you're doing like maybe long sessions in calibration, or maybe a mixer is doing long sessions, that there's a worry of damage and protection there?
Yeah, so that's a good question. So I will say that a 2-hour experience of watching a movie should not damage your ears. Damn it. It should not. It shouldn't be a thing that when you put the thing at reference, your client's not losing their hearing. Well, there are some movies that are loud enough for long enough that, it's pretty loud. And you do end up with sustained times of 115 to 120 dB, which is well documented as causing hearing loss. So then what do? Do you put earplugs in? No, you turn the volume down. You turn the volume down, suddenly the dialogue's not as clear and the surrounds get lost. So on some systems, if I understand that the client's not going to tolerate those peaks for lots of different reasons, you kind of establish what the client's going to need. You can invoke limiters. So if you have a system that's sophisticated enough that your signal processing that you're using for equalization also has peak limiters, you can say, you know what, I'm just not going to let these speakers play 105 dB long term. And on the better ones, so in a lot of the amps we use for our speakers that are made by PowerSoft, you actually have a whole bunch of different limiting functions: short-term, mid-term, long-term. And you can actually say, well, if the sound level is loud for a certain amount of time, I'm just going to crank it. I'm just going to let the peaks turn down. So you don't pardon me, you don't have to turn down the volume. You just know that the peaks are not so loud.
Right.
Is that altering the dynamics of the movie? Yes, it is.
Sure,
You're
yeah.
changing what the director had heard, but you're protecting your client. So that's about movies, number one. Number two, when I go to a calibration, after I set everything up and before I'm starting to run test tones and pink noise, my Automotic heads earplugs go in. And yes, what they do is the better ones, they have a few different versions, but the better ones turn everything down evenly, depending on the model you have, 6 dB or 8 dB or 10 dB. They make some in-ear ones that get molded to your ear, so you can do that. And I'm using the 12 dB one, so it turns the level down evenly, not just the high frequency, which is what foam earplugs do.
Right. So that is working.
That's important, and I'm saying this for anybody who's out there calibrating either with sweeps, which is short, or pink noise, which is common. That a few hours of listening to pink noise and your hearing is, if not damaged, it's tired. So then when you finally get to listening to your work, you're not listening straight anymore. So you do want to have some kind of mild earplugs in, so you turn that level down.
Excellent, excellent. Well, guys, thank you so much. That looks like that's all the questions. If you had any questions that maybe needed a little more attention or longer answers or whatnot, feel free, guys, email me those questions, jason@avproglobal.com. I'll be sure to field those to Anthony, and we'll post up all the responses and whatnot on either the AV Pro or the Meridio forums. Anthony, it looks like you've got your contact information up there. Guys, feel free to screenshot that if you need to contact Anthony for anything. Anthony, thank you so much. It was a great session. Everybody else is kind of just saying thank you from here. So I think that was a nice session for today.
Very good. I notice here I have please fill out evaluation forms. That's because like a lot of other lectures, this is a derivative of something I've taught at some CDA conference or something. So yeah, please fill out the evaluation forms and give them to your significant other and tell them why you were on the phone for all this time.
Yeah, exactly.
So thanks so much for listening and all your questions. Those were really, really cool.
Yeah, great
if you need to reach me, here's the info. If you have a kind of a generalized question that you want to make sure the whole, like Jason said, the whole audience actually gets and can benefit from, forward it to Jason, who will forward it to me. If you want to talk about room designs, if you want to talk about speakers, if you want to talk about acoustical treatments, we have all of that. You can shoot me a quick note and we can help you out. So
excellent. Well, thank you guys so much again, and we will we'll see you on the next one. I think we'll be getting together again next week. And everybody enjoy this nice 4-day week, and we'll see you next time.
Jason, for everybody and my knowledge, next week is Monday or Tuesday? Monday, right?
Next week we can probably get back to regular schedule Monday, I think.
As you want, whatever feels good. Just let me know. All right, thank you guys. Bye-bye.
Thanks, guys. We'll see you next time.